Hello and welcome to this week's episode of Security Scan. I'm Vishal Dahiya, and today we're going to talk about hypersonic technology. Now, the Defense Research and Development Organization, that is DRDO, has successfully demonstrated its prowess at hypersonic technology with a test flight of HSTDV, that is Hypersonic Demonstrator Technology Vehicle. We will try and understand more about not only HSTDV but also about hypersonic technology, its use, and as far as India is concerned, what has been the journey of development of this particular technology. And for more on this, we're joined by a distinguished panel of guests. Let me first introduce them to you, beginning with Dr. V.K. Saraswat. He is the former Director General of Defense Research and Development Organization, that is DRDO, and closely involved with the hypersonic technology development. We also have with us retired Lieutenant General Dr. V.K. Saxena, who is a distinguished fellow from VIF, and we're also joined by Mr. Ajay Banerjee, the defense correspondent of the Tribune. Welcome all of you gentlemen to Rajya Sabha TV. Let me begin with you, Ajay, and let's start by putting things in perspective for our viewers. Why are we talking about hypersonic technology here? What's so important about this test flight of HSTDV?
See, Vishal, first of all, we must congratulate the DRDO, which has conducted the successful test 2-3 days ago, and also the ISRO, the Indian Space Research Organization, which was participating in it in a big way. Both these organizations have done a great job in conducting this test. Why? Because, see, there are 3 countries which are trying to put in a hypersonic missile in place. Those are US, Russia, and China. The developments, of course, are secret what has happened because they naturally remain the domain of strategic affairs. Now come to our country. Why it is important? First of all, I must say it is a natural climb for the DRDO, since the DRDO has got a major success in making missiles of various types, configurations, and distance they travel. Now, being a natural climb, I say why it is a natural climb. We were making a BrahMos, which is 2.8 Mach speed. This will be traveling at almost 6 Mach. That you can imagine the enemy will be facing a missile which will be traveling at double the speed of the BrahMos. We had the BrahMos as the fastest missile in an arsenal. This will change the dynamics. Now, why just the BrahMos? It will change the dynamics. This kind of technology will also change the dynamics for what we are talking about, a land attack cruise missile, which can be launched from land and also launched from sea. It can have a multiple effect on the various missiles we make and target the enemy with. These are basically attack missiles.
Okay.
These will be basically attack missiles. Now comes the third part of it, which is, of course, the strategic domain. The speed of the strategic missile can possibly also be increased with this new technology which we are developing. The technology which we developed is called, I will let Dr. Saraswat speak about it in great detail. It's called an air-breathing technology. This removes a lot of glitches when the missile is traveling. It will have greater accuracy, faster speed, and of course, it places you at a pedestal, the country at a pedestal where others are also thriving, and you reach a sort of a global high table in this technology. Vishal?
Okay. Let me bring in Dr. Saraswat here, since you also mentioned it would be really prudent to have listened from the man himself. Dr. Saraswat, let's first understand what exactly is an hypersonic technology, going beyond what Ajay has pointed out, and the test flight of HSTDV, how significant it might be.
As technologically, it is a very significant step. As Ajay has been mentioning, it's a climb from subsonic to supersonic to hypersonic. And in the today's warfare, speed is the essence of the matter. So having achieved subsonic cruise missiles, having achieved the development of BrahMos class of systems, which is supersonic cruise missiles, our endeavor was to reach the hypersonic speeds. But hypersonic speeds require a different kind of a propulsion system if it has to cruise. And that propulsion system is called scramjet propulsion system, in which hypersonic wind or air that comes into the combustion chamber has to be burnt with the fuel at supersonic speeds. And that is the crux of the matter. And most of the time, the flame gets extinguished and you are not able to get the required thrust for propelling the missile. That is the technology which DRDO has been successful in developing and flight testing on the test which was conducted on 7th of September. It is a breakthrough in terms of propulsion technology, in terms of aerodynamics technology, as it is a breakthrough in terms of the technology of materials. Because when a hypersonic vehicle travels at an altitude of 30 kilometers, the temperatures on the skin of the missile reach as high as 1400 to 1500 degrees Celsius, and none of the materials can sustain that kind of thermal load for sustained duration. So DRDO had to develop specific materials, carbon, silicon carbide, and variety of things, and also develop special algorithms to test the hypersonic aerodynamics, that is the intake and the other things and the nose cone and things like that. So all this was a complex mixture of technologies to which enabled this test, the success of this test. And I must say that the scientists across the different labs of DRDO, the materials labs, the propulsion laboratories, the aerodynamics laboratories, and all of them put their head together, integrated a system what we call today as the Hypersonic Technology Demonstrator Vehicle over a period of time and successfully launched that.
Okay.
This is not, yeah.
Yes, please continue. Please continue, Dr. Saraswat.
This has established today our capability in terms of not only designing and developing, but simulating the entire scheme of things which are required for a cruise missile to be extended over long ranges, ranging from a few hundreds of kilometers to a few thousands of kilometers, cruising at altitudes of something like 1 kilometer to as high as about 30 kilometers. So that is the kind of scenario which the DRDO is able to simulate today. This has got other applications also. It can actually, when we started this program, our intention was to develop reusable missiles. That means you should be able to deliver the payload and come back, and hence reduce the cost of delivery. So that was one such thing which can be done. It was another usage of this was basically to launch a launch vehicle using the air-breathing propulsion and then take it into the space using the rocket. That is called again a reusable booster and launch vehicle for satellite launching. And in that direction, the Department of Space did some work at that particular point in time. So all of these steps now will become a reality with this particular successful test.
Okay, definitely. It is indeed a very, very significant stage as far as development of this kind of technology is concerned. Let me bring in General Saxena here. General Saxena, not only your point of view vis-a-vis hypersonic technology, but also if you could take us through, India's journey as far as development of this technology is concerned. Dr. Saraswat spoke about how they started with a particular motive and then went ahead in terms of developing various aspects of this technology.
With Dr. Saraswat on board today, we are actually carrying history on board in our show today. Well, if I start with the Indian journey of hypersonic technologies, it started sometime in 2003 and 4 when DRDO started the design of hypersonic airframe. And Dr. Saraswat is sitting here, he will remember that he gave a presentation sometime in 2007 and 8 when he brought out the possibility of a dual use hypersonic technology. He was just talking about between the low cost satellite launch vehicle and hypersonic cruise missile. He can be considered the father of bringing the hypersonic technology by this iconic presentation. I was a part of it from the MO Directorate in 2007-8, and thereafter from 2010 to 2016, a lot of conceptual designs of hypersonic airframe took place, and their testing through various wind tunnels was carried out. These wind tunnels were obtained from with the help of Russia as well as Israel. And what they were trying to test, as the doctor was bringing out, aerodynamics, aerothermal dynamics, integration of mechanical and electronic parts, and control and guidance system at that speed. So that was around 2016-17. DRDO took another 1 or 2 years. In June 2019, they came up with a design in which the carrier vehicle was a Agni-1 platform, which had to carry a missile. Now this aerodynamic vehicle or the cruise vehicle or the hypersonic vehicle was very special, as sir was bringing out, 5.6 meter in length. It had a marvel of metal technology. For example, The titanium alloy was used for the airframe, the niobium alloy was used for engine, and the pneumonic alloy was used for outer surfaces to sustain that sort of a heat. Sir was talking about 1400 to 1500 degrees centigrade. It had also deflectable nozzle. So when this missile was launched in June 19, what happened? The missile behaved all right, but the carrier vehicle Agni 1 could not take it to its right altitude. Therefore, the shock waves which were supposed to be generated could not be generated, and the wave guider phenomena did not take place.
Okay.
So that time the defense minister made a comment, don't worry, press ahead, you will achieve success. On 7 September 20, from APJ Abdul Kalam launch site at 11:03, a vehicle was launched. A similar vehicle was launched, which was tracked by the tracking radars, the electro-optical system, the telemetry stations, as well as shipborne surveillance. And it showed perfect scramjet phenomena. It showed how the vehicle was lifted, how the separation of the cruise vehicle took place, how the scramjet phenomena was sustained over a period of time, and how Mach 6 speed was achieved up to an altitude of 30 kilometers in a 20-second time of flight. So the DRDO said this is not adequate. We have to go for higher speeds, a higher endurance, higher time of flight, so that the future launches in terms of UAVs, other systems, spacecraft, and others take place. So this significant development starting from Sir only in 2003-4, and today we are at 2020, 7 September, we have achieved history. This is the brief history of the hypersonic development.
Okay. Let me go back to Ajay here. Ajay, one very interesting aspect, since all of you are speaking about various advantages and benefits of having hypersonic technology, all in terms of strategic importance or the military use of it with respect to missiles as well. But one view is also that this kind of technology will come in very, very handy in civilian use as well. For example, low cost satellite launches as well.
Yes, Vishal, it will. But before I answer a question, I'll remind an anecdote. Dr. Saraswat probably will bear me out. You know, in the past 15 years, whenever chairmen of DRDO address international conferences at various aero shows across the world, as a reporter, I have traveled to many of these shows. The foreign press used to snigger at us at the claims of the DRDO that we'll make a hypersonic missile. I still remember, and now talking to you, I'm reminded of those faces when the foreign press used to ask questions. How will you make it? Because if I remember correctly, we were on since the Pokhran 2 blast. The DRDO was on the entity list. The entity list meant you were like the black sheep of the world. The entity list was there put by the US. And these people at the DRDO, the scientists at the DRDO, worked day and night despite being literally blackballed by the entity list over the past 2 decades to make this missile. This anecdote I wanted to remind you. Now to come back to the answer to your question, Vishal. Yes, it will have multiple launches. That is why when we opened the program, I told you about the role of the ISRO. ISRO and the DRDO will be taking off. This will be called a kind of a dual-use technology, because the ISRO will be taking part in it for a launching of the satellites. And I must remind you, viewers, ISRO has recently allowed private entities to come into space and do some work. That is also a path-breaking work the Modi government has done in the past 2-3 months. The ISRO has come out with a detailed document about it, and it actually talks about the use of the hypersonics in the future. And Vishal, I must add out here for all our viewers and listeners, now the time has come to develop it quickly, to make the missiles quickly and showcase to the world. It is a moment of pride for this country, which 70 years ago, formed from the colonial British rule, has come so far that it has made a hypersonic vehicle. Now the time has come to launch, to have these missiles in deployable state. That is what I believe should be done very quickly, Vishal.
Okay. Let me bring in Dr. Saraswat here. Dr. Saraswat, I'm pretty sure you would also agree that the benefits of having this kind of technology do not only stop at the military use, but its civilian use is really, really important, and it is likely to go ahead and bring in a lot of change in the way things are being done, specifically in the area of space exploration.
I think I would like to bring to the notice of the audience today, the whole program started with one gentleman with his ideas. His name is Air Commander R. Gopal Swami, who propagated the idea of a reusable launch vehicle for launch of satellites, in which the cost of launching the satellites will come down by 1 by 15 in terms of payload. Today, when we carry a payload on a launch vehicle, it is not more than 3% of the total weight. Whereas a vehicle which he had configured using the scramjet, what we have tested today, would be weighing, would have a payload fraction of 15%. So that will be the kind of cost reduction. This program has immense value as far as the civilian applications for launching the satellites are concerned, because it will bring down the cost of satellites launching. And certainly it has got the tremendous advantages for tomorrow's civil aviation sector also, when we run into what is called the supersonic flight testing, because the materials, the propulsion system, the aerodynamics which are developed, which will ensure that civil aviation will be benefited by all of this in terms of ferrying the passengers across the globe. So these are the things which are going to make all the great difference as far as this technology is concerned. DRDO certainly will be benefited, because today they can now design ship launch systems, they can design submarine launch hypersonic missiles, they can design today surface launch hypersonic missiles, and that will give them the complete access to the kind of scenario which we need for high-speed missile systems in the country. And mind it, in this endeavor, as Mr. Banerjee was telling, despite the missile technology control regimes and embargoes which have come, our scientists are in a position to develop indigenously all the elements, all the materials, all the algorithms, all the control, the guidance, the entire system of launching, tracking. Everything is indigenous today in this whole scenario. That shows the Atmanirbharta has been achieved in this particular segment by our scientists working throughout in the last couple of years.
Okay, definitely. It does show the resilience of the Indian scientific community. But one more, poser to you, Dr. Saraswat, before I move on to General Saxena, is how would you sum up, since you've been associated with this program since its inception, since its when it was being thought about, you spoke about the way forward and reminisced about the times when it started. But how would you sum up this journey, India's journey towards achieving this particular goal?
I would sum up in one simple word, and that is the synergy among the scientists, which has brought solutions to the immense problems which were related to the hypersonic flights. The synergy of among the material scientists, the synergy among the propulsion scientists, the aerodynamics, the structures, the control, the guidance, and the academia and the industry, and all put together. It is the combined effort of the entire nation which has propelled us to this particular level. And that is a lesson I would like to communicate today, that if we want to solve our problems of science and technology or even country, the best way is synergy and a mission mode approach to reach that particular goal. And this is the lesson which we have learned. I would sum it in this form. Working together gives you success despite all the odds.
Okay, definitely synergy and mission mode approach are the key words there. General Saxena, your views before we bring this to an end on the way forward from here as far as utilization of this kind of technology is concerned. There are lots and lots of avenues, and more will be explored and will become more clear to us in the days or weeks or months ahead.
Sir, as far as the future use is concerned, I will first like to say a few words on why the whole world is why it has become a talk of the town, or in the world over, to talk about the hypersonic weapons, hypersonic cruise missiles, or hypersonic glide vehicles. Why?
Okay.
It is because of the for a soldier. 4 different verticals of this weapon system are most troublesome for a defender. First of all, a vehicle traveling at 1.6 km per second or more than that can hit any target around the world in less than 1 hour. Now, such a vehicle hurled towards the missile defense system simply beats the cycle of the detection, identification, tracking, designation of the target, and engaging before it releases its lethal load. Therefore, the first thing is unstoppability, which as a soldier, I am looking at hypersonic weapons in this fashion. Second is undetectability. If a vehicle is hurled at a speed which is 6 Mach to 10 Mach, where is the chance for a ground-based, air-based or a sea-borne detection system to detect it unless the detection is now based on the space? Thirdly is the huge kinetic kill capability of such weapon. It can cause tremendous destruction. Now research has shown that 1 kilogram weight of warhead in hypersonic mode at Mach 6 will produce 36 times the type of warhead effect which a normal warhead will produce. And lastly is unpredictability. Unpredictability. They move at such a speed and it is all the way powered missiles. They can change their target and the mission at a short notice. Therefore, once a hypersonic vehicle is in flight, a large swath of area is under threat. Now, this hypersonic threat vehicle is not only we are trying to develop today, we have already made some inroads and inroads into it, and already they are a part of our arsenal. Let us talk of Shaurya missile. We have talked of Shaurya missile, February 2018. This is a surface-to-surface tactical missile which achieves 7.5 kilometer and with an accuracy of less than 20 to 30 meter. Dr. Saraswat is on board today. He is the father of Program AD. Program AD is the indigenous ballistic missile defense system which has got two phases. Phase 1 up to 2000 kilometer range missiles can be taken. Phase 2 5000 kilometer. In 5000 kilometer missiles, there are interceptors called AD1 and AD2. Both of them are in the hypersonic range. Now, today only there is a news of BrahMos 2 being Russia agreeing to the future supply of BrahMos 2 to Philippines and Vietnam. Tomorrow, BrahMos 2 stands at the gate of hypersonics with a promise of Mach 7 and 600 kilometer range. So the future avenues of these weapons are in the lethal zone of China and Russia and US are in the forefront. The threat is developing and we should also be prepared to counter this threat in days which are coming, in years and days ahead.
So that changes a lot of things. And before we bring this to an end, I'd like to come back again to Dr. Saraswat on the points which have been made by General Saxena there. Dr. Saraswat, looks like this particular technology will change a lot of things related to, military infrastructure and specifically missile defense.
I agree with you. And today, if you are looking at countering the threats from the hypersonic systems, is the major development area which all the military scientists have started working at. So we are in the breakthrough area, and certainly it has got tremendous impact as far as the war doctrines and war fighting capabilities of the nations are going to be concerned. And as a nation, I am proud of my scientists, my teams who have made it possible that we can boast that yes, we have this technology today and we are inferior to none. So we are in a position to now come to that level.
Ajay, concluding comments from you?
Well, we must acknowledge that the DRDO has done a great job. We are on the cusp of greatness. The country has moved towards a new paradigm. We are on the cusp of greatness. And I must also remind that DRDO also has done a test of the anti-satellite weapon just last year, 2019. That is also a very important development. So these things also, coming back to the hypersonic vehicles, they take us to a new league of nations, and we must now keep on progressing faster, quickly, and as I said earlier, bring about missiles which are deployable from land, air, and sea, and crucially, if possible, also from under the sea. That will make it actually a big development. But I hope it happens, and the ISRO will, of course, use the technology for use of launching of satellites, high seas in a multiple fashion. It will help our country grow in stature. Apart from that, as we spoke about, it was a natural climb to this, but it will help us grow in stature. Vishal, that's how I see it.
Okay. Let's wait and watch as to how things develop from there. Thank you so much, Ajay, General Saxena, and more specifically, Dr. V.K. Saraswat, for sharing your experience, your views, and your time with us. So this is all about hypersonic technology, its development, and the entire journey of Indian scientists, their resilience, as well as the synergy, and as Dr. Saraswat was pointing out, the mission mode approach to go ahead and achieve this particular target of acquiring or developing rather hypersonic technology and successful demonstration of HSTDV. We will come back again next week with a different topic. Till then, keep watching Rajya Sabha Television.